Hello students, now we are discuss the conversion of D-glucose to D-fructose. The conversion of D-glucose to D-fructose. The conversion of D-glucose to D-fructose involves three steps. In the first step, glucose reacts with 1 mole of hydrogen to form glucose phenylhydrazone. Then glucose phenylhydrazone undergoes oxidation with 2 mole of second mole of phenylhydrazine gives a carbonyl group on second carbon atom. This C double bond O group further reacts with third mole of phenylhydrazine to give ozone. In the second step, ozone undergoes hydrolysis to form ozone. In the third step, ozone undergoes reduction with zinc and acetic acid to form fructose. Dear students, the question is D-glucose to D-fructose. We prepare D-fructose from D-glucose. In this situation, this is the procedure. This is the procedure for D-glucose to D-fructose. The conversion of D-glucose to D-fructose involves three steps. First step is formation of ozone. Second step is formation of ozone. Third step is formation of fructose. Now, these are the chemical equation. This is chemical equation glucose. We know that glucose structure. Once again, I remember 4 lines. In bottom side, CH2OH group is present. From top side, aldehyde group is present. From top to third carbon, OH group is left side, hydrogen, HOH, 4 HOH are there. This is the glucose structure of glucose. This is the structure of glucose. When glucose reacts with phenylhydrazine, PHNH-NH2 is phenylhydrazine. PHNH-NH2 is phenylhydrazine. When D-glucose reacts with phenylhydrazine to form D-glucose phenylhydrazone. In this situation, H2 interacts with carbonyl oxygen to form H2O. This is the loss of H2O molecule. By loss of H2O molecule, PHNHNN is added to C double bond O carbon. And then D-glucose phenylhydrazone reacts with second mole of phenylhydrazine. In this case, phenylhydrazine is act as reducing reagent. So it's act as reducing agent. So it's remove one hydrogen molecule. Phenylhydrazone remove hydrogen from D-glucophenylhydrazine. So in this situation, 2 hydrogens are removed by D-glucose phenylhydrazone. This acts as reducing agent. So finally we get this product. So on second carbon we get C double bond O. So the second carbon is converts to C double bond O in the presence of phenyl hydrogen. The second carbon is converts to C double bond O, remaining is kept constant. The second carbon is converts to C double bond O by using second mole of phenyl hydrogen. And this compound, this carbonyl group further reacts with third mole of phenyl hydrogen. This carbonyl group further reacts with third mole of phenyl hydrogen to form wasazone. This is the wasazone. The reaction further not proceeding. Why? Because here in this wasazone hydrogen bond is formed. Hydrogen bond is formed. So the reaction further not proceeding. The wasazone undergoes hydrolysis. The wasazone undergoes hydrolysis to form ozone. This is the ozone. What is our aim? Our aim is D-glucose to D-fructose. Already we know that D-glucose, this is the D-glucose. D-fructose is, this is the D-fructose. What is the difference between these two? What is the difference with these two? In this case CH2OH is present, in this case C double bond O. So that's why this is the ozone. Further ozone undergoes reduction in the presence of zinc in acetic acid. Ozone will undergo reduction with zinc and acetic acid. So zinc and acetic acid affected only one group. Only aldehyde group is affected by zinc and acetic acid. Remaining all are kept constant. Remaining groups are not affected by zinc and acetic acid. By using zinc and acetic acid, only one functional group, that is aldehyde group, is affected. Remaining functional groups are not affected by zinc and acetic acid. So here C double bond OH will convert to CH2OH. C double bond OH will convert to CH2OH. This is the chemical equation for D-glucose to D-fructose. Students, we take D-glucose. When D-glucose reacts with phenyl hydrogen, we will get D-glucose phenyl hydrogen. D-glucose phenyl hydrazone will react with second mole of phenyl hydrogen. So we get this type of product. This product further in this C double bond O carbon further reacts with third mole of phenyl hydrogen. So finally we get wasazone. But for the formation of wasazone, we required 3 moles of phenyl hydrogen. For the formation of wasazone, we required 3 moles of phenyl hydrogen. It is very important question. This is asked in practical viva. This question will ask in practical viva. So the wasazone undergoes hydrolysis to form ozone. Ozone further undergoes reduction with zinc and acetic acid. Finally we get D-fructose. fructose. This is the D-fructose. This is the O-zone. This is the osazone. This is the osazone. This is the conversion of D-glucose to D-fructose. Very simple. Finally, D-glucose to D-fructose. The difference is D-glucose to D-fructose. I remember this. D-fructose is C double bond O CH2OH, 3 lines, CH2OH, OH, H, H, OH, H, OH. For suppose we write this is the fructose. This is the fructose. For suppose in this carbon HOH, in this carbon C double bond OH, that is the glucose structure. I write clear. Glucose, 4 lines, CH2OH, C double bond OH. On third carbon OH is left side, HOH, HOH, HOH. So the difference between glucose and fructose here, on second carbon carbonyl group is present. On first carbon CH2OH group is present. So first we convert HOH, C double bond O, HOH is convert to C double bond O, and then finally we get CH2OH. That is the procedure for conversion of glucose to fructose. That is the procedure for glucose to fructose. Hello students. Now we discuss another more important question. The conversion of D-fructose to D-glucose. The conversion of D-fructose to D-glucose. The conversion of D-fructose to D-mannose. Dear students, these two questions are different, but only one method for answer. So first we discuss procedure. What is the procedure for D-fructose to D-glucose? The conversion of D-fructose to D-glucose and D-mannose are as follows. In the first step, D-fructose reacts with H2 in presence of nickel catalyst to form a mixture of D-glucital and D-mannitol, and then glucital and mannitol undergoes oxidation with HNO3 to form D-gluconic acid and D-mannanoic acid. These acids further undergoes dehydration, means loss of H2O in the presence of heat to form gamma lactone. This gamma lactone on reduction with sodium amalgam to gives D-glucose and D-mannose. This is the procedure. This is the procedure for conversion of D-fructose to D-mannose. Conversion of D-fructose to D-glucose and D-mannose. So now the chemical equation illustrated as follows. This is the chemical equation: D-fructose to D-glucose, D-fructose to D-mannose. Now D-fructose, the starting material is, the starting compound is D-fructose. This is the D-fructose. On second carbon, carbonyl group is present. On top CH2OH, bottom CH2OH. In the third carbon, OH is left side. This is the fructose. Fructose reacts with hydrogen in presence of nickel catalyst, that is H2Ni. We get mixture of products. We get these two mixture of products. One is D-glucital, another one is D-mannitol. Further, this mixture undergoes oxidation with HNO3. Undergoes oxidation with HNO3 to form gluconic acid, mannanoic acid. Gluconic acid, mannanoic acid. This gluconic acid undergoes dehydration, means loss of H2O in presence of heat, to form gamma lactone. What happening here? CH2OH converts to COOH by reference COOH. Second carbon is alpha carbon, beta carbon, gamma carbon. On gamma OH, HOH will interact to each other to form H2O. This is the loss of H2O. So these oxygen, this carbonyl carbon to form new bond between this oxygen and C double bond O carbon to form new bond. This is the new bond. So here gluconic acid undergoes dehydration in presence of heat to form gamma lactone. Gamma lactone undergoes reduction with sodium amalgam. Undergoes reduction with sodium amalgam to form D-glucose. Here gamma lactone undergoes sodium amalgam. We get D-mannose. That is the difference. Students, here first of all, our aim is D-fructose to D-glucose. So what is the difference? D-glucose, D-fructose. Here aldehyde group is there in D-glucose. Here HOH is there. So first we convert this C double bond O group into HOH. This C double bond O group into HOH. Here in these two products, the difference is what is the difference mean? The difference is on second carbon. On second carbon, in glucital, on second carbon OH is right side. In mannitol, on second carbon OH is left side. That is the difference. Only C2 configuration is changed. Remaining all are kept constants. So first we get this C double bond O group, we will convert to HOH. After then this CH2OH converts to COOH. After then this COOH converts to aldehyde group, gamma lactone. On reduction we will get D-glucose. This is the conversion of D-fructose to D-glucose. Another question, D-fructose to D-mannose. The procedure same, undergoes oxidation and undergoes dehydration and undergoes reduction. This is the here also same, oxidation, dehydration, reduction. So two questions are different but only one method for answer. So this is the D-fructose to D-mannose, D-glucose. This is also very important conversion. Students, 4 conversions are there. One is D-arabinose to D-glucose. That means 5 carbon carbohydrate to 6 carbon carbohydrate. It is also known as Killian-Fischer method. 5 carbons to 6 carbons. Reverse, rough degradation. 6 carbons to 5 carbons. 6 carbon means D-glucose, 5 carbon means D-arabinose. D-glucose to D-arabinose, it is known as rough degradation. That is the two important conversions. And finally, glucose to fructose. Glucose to fructose, reverse, fructose to glucose. First of all, we know very important discussion, what is the structure of D-glucose. Like this, in bottom side CH2OH group is present, on top C double bond O H group is there. So third carbon, this is the third carbon. OH is on left side, H OH H OH H OH. This is the structure of glucose. For suppose, if fructose, we can draw fructose, here C double bond O, here CH2OH. That is the only difference between glucose and fructose. Second, mannose. Students, mannose, I can draw mannose. These are the 4 lines, CH2OH, C double bond OH, C double bond OH. On second carbon, OH is left side, H is right side. Third carbon also, OH is left side, H is right side. H OH H OH. This is the mannose. What is the difference between glucose and mannose? Means, this is the difference, this part the difference. In glucose, H is left side, OH is right side. In glucose, H is left side, OH is right side. In mannose, OH is left side, H is right side. This part will kept constant in D-mannose and D-glucose. This part will kept constant in D-mannose and D-glucose. This is the same. It is also same. D-mannose and D-glucose. This part is difference in glucose and mannose. That is the main difference between glucose and D-mannose. Next, what is the arabinose? What is the structure of arabinose? This is the, already we know, CH2OH. Once again I remember C double bond OH. This is the I am right glucose structure, H HOH HOH. This is the glucose structure. In glucose structure, once again I can draw glucose structure, CH2OH, C double bond OH, HOH, OH group on third carbon left side, HOH, HOH. So the difference is, if this is removed, we can get D-arabinose. First you can write D-glucose structure. After you remove the second carbon, the second part. Remaining is the structure of D-arabinose. This is the structure of D-arabinose. Next, fructose. You can draw 3 lines only. On second carbon, you can draw C double bond O group. On top CH2OH, bottom also CH2OH. On third carbon OH is left side, HOH, HOH. This is the fructose. So four structures are very very important: glucose, mannose, fructose, arabinose. Glucose, fructose, mannose, arabinose. These four structures are very very important. So four conversions, arabinose to glucose, glucose to arabinose, glucose to fructose, fructose to arabinose. Four conversions are very very important.